right, so October 2nd. And section 2-4. And we're introducing the chain rule. Okay, so chain rule deals with composite functions. All right, you have to have a composite function. And we did composite functions in pre-calc. All right, so let's take a look at some of the functions that we've been dealing with so far, and then some of the composite functions that we will start to deal with. All right, so without the chain rule, because you have been doing derivatives now, actually, for quite a while. All right, without the chain rule, because I haven't said anything about it. All right, and all of our functions look like maybe say y equals x squared plus 1. Okay, that's just like a regular old nice little parabola, nothing to it. We've messed with some trig, all right, but every trig function up to this point that we have dealt with has just had an x right there. It's been sine x, or it's been cosine x, okay? We've done ones like, y equals 3x plus 2. Again, they're just straight functions. They are not composite functions. But now what we're going to be able to do with chain rule, we're going to be able to do composite functions. So like y equals the square root of x squared plus 1. Now remember those from last year? You remember when I asked you to find the inside and then find the outside, and I told you to write an h of x function and tell me where f of x was and where g of x was? Okay, that's what I was trying to set you up for this. All right, if I look at the square root of x squared plus 1, what's the inside part of this function? The x squared plus 1. What's the outside part of the function? The square root. When we do chain rule, you've got to be able to find the inside of the function. You got to be able to find the outside of the function. Okay, if I had y equals sine 6x, and again, we know I generally don't put the parentheses around there, okay, but technically they're there, okay? So on that one, where's the inside part of the function? 6x. What's the outside function? Sine, not sine x, just sine. Let's just say sine, okay? Inside is 6x. The outside is sine, okay? If I did y equals, say, parentheses 3x plus 2 raised to the 5th power. Okay, inside part is 3x plus 2. Outside is x to the 5th power, or something raised to the 5th power. All right, so we're clearly going to have an inside and an outside. All right, now let's introduce the chain rule. And again, I'm going to use some notation that you're going to see in your book. All right, let's say we're doing d dx. So we are taking the derivative of a composite function. So it's going to look like f of g of x, using that function notation that we are used to. Okay, so what we're going to do, I'm going to verbally say it and then write it as I say it. We're going to take the derivative of the outside function, f prime, leave the inside function alone, and then multiply it by the derivative of the inside function. I'll give you time to write that down, then I'm going to say it again. We take the derivative of the outside function. We leave the inside function alone and multiply it times the derivative of the inside. All right, and this is the key part that people screw up on. You take the derivative of the outside function, leave the inside alone, don't touch it, right exactly as you see it. Multiply it by the derivative of the inside. So we're going to use the d dx notation to help us know when and where to do that with. Okay. All right, so keeping that in mind. So as an example, we'll start out with nice little easy ones and we'll work our way up. Let's say we've got f of x is equal to x squared plus 1 raised to the 3rd power. Okay, where's the inside function? x squared plus 1, right? Outside function is something being raised to the third power. So if for my outside function I want to take the derivative, I've got something raised to the third power, I'm going to use the what rule? Power rule, right? I'm going to do power rule. So I'm going to have f prime of x. I'm going to take that derivative of that outside function, which is the power rule. So I'm going to pull the 3 down in front. I'm going to leave the inside function alone. I got to subtract 1 on the x. And then I'm going to multiply it by the derivative, d dx, of that inside function. My outside function is something to the third power, so I'm doing power rule. I'm going to do the power rule. I'm going to pull the 3 down in front, subtract, leave the inside alone, times the derivative of the inside. Okay, now I can go to the next line. The 3 stays put. X squared plus 1 to the second power stays put. Derivative here is 2x. So right there, I'm going to have 2x. All right, and then your last step is just clean that up. Okay, 2 times 3 is going to give me a 6. I'm going to put that 6x out in front. X squared plus 1 to the second power. All right, it's going to help you if you say that every time. Derivative of the outside, leave the inside alone, times the derivative of the inside. Okay? All right, so do we need to do another one just like that one? Just for here, I'll let you try it. Let's do f of x is equal to, so another nice little power rule, 3x minus 2x squared to the third power. Okay, do it the exact same way. Inside, 3x minus 2x squared being raised to the third power. Derivative of the outside function, leave the inside alone, times the derivative of the next one. I'm going to pause my screen, although it's not pausing it in the video, but it's pausing it for those in class. Okay, so for those people who are in class, I'm going to show what I've done so far. All right, pulled the 3 down, subtracted the 2 here, took the derivative here. Okay, now, did anybody go farther? Dane, what'd you do? How did you simplify this? Yeah, see, this is where different people do different things. All right, and if you put the 3 here, you bring that out here in front, and then times the 3x minus the 2x squared squared. All right, a lot of people leave it like that. A lot of people will then distribute and have a 9 minus a 12x. Now, do you have a set of parentheses around that? Yes, because if you do that, that's a quantity, that's a binomial. You need that set of parentheses around there. Okay, all right. So that was just 2 examples really close together. Okay, power rule is not too bad, and power rule is not too bad like that. Okay, so I don't really care. There we go. We'll just circle both of them. Okay, now let's do one where you've got to do some algebra manipulation first. Okay, so algebra manipulation first. How about something like f of x is equal to the square root of an x to the third plus a 2x, and x to the third plus 2x. Okay, so first thing I'm going to do is what? I'm going to take that square root and I'm going to turn it into a 1/2 power. Okay, so I'm not taking the derivative, so no f prime of x. I'm just keeping the f of x there. X to the third plus 2x to the 1/2 power. All right, I really would highly recommend that you actually rewrite it. Don't try to do it in your head. All right, now I'm ready to do my derivative. Okay, clearly this is just another power rule, right? I have inside here, it's being raised to the 1/2 power, so I'm going to pull the 1/2 down in front. X to the third plus 2x. So do the derivative of that outside function, leave the inside function alone. What's the 1/2 minus 1? Negative 1/2 times the derivative of the inside, so d dx of x to the third plus the 2x. All right, now on this next line, I'm not going to worry about that negative exponent right now. I'm going to go ahead and focus on the derivative here. So I'll have the 1/2. I'll have the x to the third plus the 2x to the negative 1/2. All right, now derivative here, 3x squared plus 2, kind of together there as a binomial. All right, now this 2's in the bottom. This needs to go to the bottom, right? Where does this go? This stay? Yeah, this stays in the top. All right, so the 3x squared plus 2 stays in the top. The 2 is already in the bottom. This whole thing is going to the bottom. It'll make this a 1/2. And then can I turn it back into a radical all as I move it down there? So I can go square root of x to the third plus 2x. All right, now I'm going to tell you where the number one mistake occurs most often on power rule. Like we're doing this, we've got to do a chain. We pull the 1/2 down in front, so everyone pulls the 1/2 in front. They either mess with this or they don't. I would like for you not to. Inside stays the same. The number one forgotten thing, people forget to do something to that exponent. You always have to subtract 1. So it either gets dropped altogether or they just carry down whatever exponent was there because people just forget. So right there, that's the one you want to check when you're checking your work. All right, derivative of the inside. All right. Yeah, that happens. Yeah, something as simple as that, but then it does mess with it. Okay, so let's do, I don't know how many more we have to do like this. Are we pretty good on the overall concept of chain so far? Okay, all right, so now, could I put chain inside the product rule? Yeah, could I put it inside quotient rule? Yes, yeah, I know, please don't, but unfortunately, yes, that's where we're going with this. All right, so you know product rule, you know quotient rule, and now I've done chain, so we're going to put them inside those. Okay, so stepping it up a little bit here. That's supposed to be an e or ex. All right, let's suppose they give you a function that's like x squared times the square root of 1 minus x squared. The ddx notation is going to be extremely important. All right, clearly there's our times. So this is a product rule, okay? So I'm going to start with my product rule. So I'm going to go f prime of x because I'm starting my derivative. We do the first function. We leave it alone. We do times the derivative of the second, ddx. All right, I want the ddx notation in here. Now, I would, instead of writing square root, on this one, I know I'm taking the derivative of that. I would probably go ahead and write it as 1 minus x squared to the 1/2 power. Go ahead and get it set up so that you can see it. All right, and then plus the second function, so square root of 1 minus x squared times ddx of the x squared. All right, so right there, the only thing I did was just set up for my product rule. Okay, now I'm going to have my x squared. Now, this is where, when you look at this derivative, you've got to see there's a chain. Okay, so I'm going to still do power rule, so I'm going to pull down the 1/2. I'm going to leave the inside alone. 1 minus x squared. 1/2 minus 1? Negative 1/2. And then because it's a chain, times the derivative of the inside. So times ddx of 1 minus x squared. All right, so that, and I'm going to highlight it in orange. So it just extended the work there really, really long. Okay, so all of this became all of this. Now I'm ready to keep going. That plus sign has to come straight down. The square root of 1 minus x squared. Derivative of 2x, that's an easy one. So that's just a 2x. So see what it did is it caused another line for derivative. So now I've got to do the derivative here. Everything else is going to stay the same. So I'm going to have an x squared. The 1/2 is going to stay the same. 1 minus x squared to the negative 1/2 is going to stay the same. Okay, now I'm ready to do the derivative here. And on this one, that's just a straight derivative, right? 1 goes away. That becomes a what? A minus 2x to the first. And then everything else I just write down again. All right, it really doesn't matter at what point you put that in front. Okay, I don't know. I'm going to go ahead and put it in front. 2x square root of 1 minus x squared. Okay. This 2 is where? Top or bottom? This 2 right here is where? Yeah, this is on the top. This is on the bottom, right? So can they cross out the 2's? All right. This x squared is on the top. So how many x's do I have on top? X to the third with a negative. Okay, so let's go ahead and get rid of the 2 and the 2. All right, so I'm going to have a negative x to the third on top. Because right now, all I am doing is trying to put this together in a nice, neat little thing here. Okay, so I'm going to have a negative x to the third. All right, this has a negative exponent. So it comes down to the bottom and becomes positive. Okay, now I'm not going to turn this one into a square root yet. So I'm just going to move it down here and leave it to the 1/2 power. Oh crap, not an equal sign. Why did I put an equal sign in there? Plus. Okay, now this right here, is this a fraction? No. Is this a fraction? Yes. Yes. I'm going to set this up for common denominators. So I'm going to go 2x. All right, now on this one, look at the consistency here. Are my inside the same? 1 minus x squared. This is to the 1/2 power, which is a square root. This is a square root. I want it to match so I can manipulate it here a little bit. So I'm going to go 1 minus x squared to the 1/2. I'm going to go ahead and do that and put it over 1. This is the algebra on steroids part. Okay, now what do I want? I need common denominators to be able to add this. So, yep, take this, because that's what I want my denominator to be, and multiply it by that over itself. So 1 minus x squared to the 1/2 over 1 minus x squared to the 1/2. That's going to get me common denominators. Okay, now on my next line, since I know that's my denominator, I'm going to write it once. So 1 minus x squared to the 1/2 power. I'm going to leave it 1/2 power for right now because I don't know what I'm going to do with it. Now, take a look at this. When we multiply like bases, what do we do to the exponents? Add them. So if I multiply like bases, I add them. 1/2 plus 1/2 is 1. So really, I have what? Just a 1 minus x squared. When I multiply these two things, I just have one of those. Okay, so I'm going to write this term down, negative x to the third. I'm going to write 2x down. But then because I'm multiplying these two things, I have a 1 minus x squared. So it looks like I can do some distributing there. I'm going to go sideways because I'm running out of paper. All right, so a negative x to the third, distribute this 2x plus 2x minus 2x to the third all over. I might as well go ahead and put that now back into a square root because I'm not doing anything with it. I've got some like terms. Looks like I can simplify a little bit farther. Let's see, negative 1 minus 2, so minus 3 x to the third plus 2x all over the square root of 1 minus x squared. Now, there's no reason to factor out an x on top because I can't cross it out, so there's no point in factoring at that point. Okay, so now it just became a whole lot more difficult. All right, and not really more difficult, because in all honesty, how much calculus are you really doing? From the first line to the second line, you implemented chain rule, which you know the chain rule. That was easy. You're not going to make a mistake there. All right, when you went from the second to the third line, you did have to catch this was chain, but there's a second line that has calculus in it. All right, but from here all the way down to the end, it's nothing but algebra 2. I probably said the wrong thing. Did I say that? It's product rule in the first one, and then it's chain rule in the second one. My point being, the calculus itself is not hard. You do product, then you do chain. All right, it's all of this algebra stuff that screws people up. Okay? Yes, that happens. If you end with two things that are being added like this, and one of them's a fraction and one is not a fraction, you have to get common denominators and put it together so that you have a nice single answer. Okay? All right, let's try it again. Let's do one that looks like f of x is equal to, let's do like a 3x minus 1 all over an x squared plus 3. And let's raise it to the second power. Clearly, we got a composite function. We got an inside, we got an outside. My inside function is what? A quotient? Okay, so that means we're going to have quotient rule in here. Okay, but I'm ready to start. I don't need to simplify. I don't need to do anything first. I'm going to start. I'm going to come all the way over here because I don't know how much room this is going to take. F prime of x. All right, this notation is extremely important because you're telling the person, hey, I'm starting my derivative. All right, we're going to implement the outside derivative of that outside function. So we're going to pull the 2 down in front. We're going to leave the inside alone. So 3x minus 1 over x squared plus 3. And then subtract 1. I would write it in there just so that you don't get in the bad habit of not putting something up there. Times d dx of the inside times the derivative of that inside function, which is a 3x minus 1 all over x squared plus 3. So that's just implementing chain rule. Okay, the only thing here I'm going to have is quotient rule. I'm going to keep all of this the same. All right, at any point in time, could I take that 2 and put it up on top? Yeah. So, and like technically you could even go ahead and distribute it. I think at this point it would be fine. So I could do like a 6x minus a 2. I mean, you can leave it factored out. You can put it in. I don't know at the end that's going to make a big difference here. All right, so when I start doing derivative here, so it's the bottom. I'm going to put a square brackets around this because I don't know what the heck's going to happen in here. So derivative of the bottom, the bottom, low d high, times the derivative of the top. Now, can you leave out the d dx notation on this? Yeah, okay. So derivative of the top would be 3 minus, put in an extra set of parentheses there, the top, 3x minus 1, times the derivative of the bottom, which is just going to be 2x. All over the bottom squared, x squared plus 3 to the second power. Okay, and this is just a multiplication here. So I'm going to have a 6x minus 2. I'm going to have my x squared plus 3 here. All right, so let's mess around with this up here. Distribute that 3. So 3x squared plus 9. All right, now, so we can, I don't know, I don't want you doing a lot of things all in one step here. Distribute the 2x, that's going to give me what, a 6x squared, and it's going to be minus, right? Minus 6x squared. Distribute the 2x, the negative times the negative is going to be a positive. So positive 2x. Did I do too many steps in one? Are we good? Now over here, this is a polynomial. Looks like I can add some like terms there. This is a binomial. I'm going to have what power on the bottom? To the third power, right? Because this is when multiplying like bases, add the exponents, okay? So I'm going to put it over 1, so I'll have that 6x minus 2 let's clean that one up a little bit here. Is what? Minus 3x squared plus 2x plus 9. And then an x squared plus 3 to the third, we said. Now here, again, debatable. Do I want to go ahead and FOIL all that out? Not really, because you're more likely to make a mistake. I am good with stopping right there. I mean, we did a little bit of distributing. We cleaned that up. We combined some like terms over here. It's a moot point whether or not you go ahead and multiply all that stuff out there in the top. I probably, at that point, would just stop. Because I don't want you to keep going and keep going and keep going so far that you... Okay, so those are trig. So these are for the next day. All right, so I think we're going to do chain rule multiple times. Notice I did not do any trig functions. All right, it was just nice with polynomial functions and quotients. Okay, so we're going to practice this. All right, I want the ddx notation so that you see that chain. I don't think you will have to do a chain inside the chain. I don't think you'll have to do it twice on this first assignment. All right, so that'll be forthcoming later. On Monday, we'll hit trig ones. We'll do chain on that. And then I will try to do some pretty hard examples in class. All right, just because like you need to see hard ones, not just always easy ones. But I started with easy ones because I think today's assignment is going to be relatively easy. There you go. That was very elegantly stated there. All right, so you got the rest of the period to work, which I know is not tons of time. All right, anybody have questions at home? Just checking because somebody is there on a loaner computer, so I don't actually know who's with me. Who is that? Is that Kendi or Elena?
Elena.
Okay. All right, just checking. All right, so I think I'm good. If you don't have any questions, I'm going to go ahead and end the meeting.
All right, I'm good.
Okay.